Deep learning is all about approximating a complex function using gradient descent. You can see this simple function where we want to find the minima. We start with a random value of x and find the value of x which minimize the value of y. Starting from x equals 1.5. Let's observe gradient descent as it finds the minimum of our function. It's important to note that this function isn't the one we're trying to approximate, but rather the loss function we aim to minimize. Next, we will explore this in detail. Let's explore the gradient descent with these three plots. The other two graphs help visualize the learning process. As we vary the input x, you can see how the model's output and the loss change accordingly. This equation defines our model's output as a simple linear function, which is visualized in the first graph. Our goal is to train this model to approximate a set of data points representing a linear relationship with some noise. The second equation calculates the loss, the squared difference between our model's output y and the target y hat, visualized in the second graph. The input x comes from our dataset. We can vary it to see its effect on the model's output and loss. Y is the output predicted by our model, based on the current input x and weight w. And y hat is the target value, the correct output we want our model to learn to predict. The objective is to minimize the loss, which is the difference between the predicted and target values. We do it with gradient descent. You can see it in third graph. The current y hat value is 0, but we can adjust it to observe its impact on the loss.